So the cycle of the seasons is caused by the Earth going around the sun while it's tilted on its axis. Now it tilts on its axis, but it maintains that same tilt relative to the universe, right? Which means that it changes it relative to the sun. The North Star is always directly due north. It's kind of an interesting thing. I don't know if you've ever been able to find North Star, the Polaris in the sky, but the Earth's axis is always pointing straight at it. That's why it stays north no matter where you are, and no matter what time of year it is either. Okay, so it maintains the same tilt relative to the universe as it goes around the sun. So I don't know if you can see very well in the video. We'll find out here how well this works. Can you see how the Earth here is tilted that way? Right? This is what I like about it. The equator kind of goes like so, right? This is what I like about it, because watch what happens when I turn. This would be like in the northern hemisphere, summertime, tilted toward the sun. But as it goes around, now on the other side, it's keeping the same tilt in the direction. It's still pointing at the same part of the ceiling, but now it's the northern hemisphere is tilted away from the sun instead of toward it when it's on this side, and the southern hemisphere is tilted toward it. So again, that tilt stays the same relative to the room, but that means that relative to the sun it changes. You see what I'm saying? That's what the Earth does. The Earth is tilted on its axis as it spins, as it rotates day in and day out. But that means that the year, you got these times of year where it has more direct sunlight and where it has less direct sunlight. If you live not on the equator, right? Or on the poles, it always stays pretty indirect, but at least you get some light. Here's an interesting thing. You probably know this, I hope. If you're over here, the North Pole is where I'm pointing to right now. Notice that there's no way that the sunlight gets to the North Pole no matter what time of day it is. So it stays dark for 24 hours a day. And then if you get in the North Pole on the other side, when it's summertime, see here's the North Pole here. Well, that means that the sunlight is shining on it. And no matter what time of day it is, the North Pole is always, that's why land of the midnight sun, right? It stays dark, or excuse me, it stays light 24 hours a day. And what happens there, the sun doesn't rise and fall, it just goes round and round. Okay? And as it gets closer to fall, gets closer to the horizon, then it skims the horizon and then it goes underneath and then it's dark for 6 months. And then it comes back up and it's skimming where you have a sunrise happening in every direction for, and then it gets higher in the sky. And then you have 6 months of darkness, 6 months of light. Okay, so that's what happens at the North Pole, which is pretty weird, but that's the way it is. Now, let's kind of move on with what we're doing here. There's a little vocabulary words I need you to get here. On this cycle of the seasons, then, you have where it's the maximum tilt toward the sun. That would be what's called the summer solstice. That's the first day of summer, right? And then it goes through the season of the summer until it's like this. Oh, it's this. It's like getting a solar eclipse here. Now it's tilted this way. It's not tilted toward the sun or away from the sun. 12 hours a day, 12 hours a night. That would be, then winter, spring, summer, fall. So fall, this is the first day of fall. That's the autumnal equinox. Equinox means equal night. The night and day have equal length. Okay? And then it continues going like this until we get to the maximum tilt away from the sun. That is the winter solstice, the first day of winter. And so we just had fall. Now we got winter. And till we get to the vernal equinox or the spring equinox. Okay? And then we get back to the summer solstice. Now, a lot of people think it's kind of strange, but it's true. That means that as you're going through summer, the days are actually getting shorter. But remember, it still gets hotter after the middle of July isn't necessarily the hottest part of the year. August sometimes is hotter because every day it absorbs more energy than it loses at night. So it continues to get hotter until it starts losing more energy than it's gaining, which is also why when you have the first day of winter isn't necessarily the coldest. That's like in December. Sometimes January, February is colder because it's losing more heat than it's gaining over the course of the winter. But during the winter, the days are still getting longer and longer, right? Which, again, a lot of people are like, what, really? Yeah, the first day of winter is the shortest day of the year. But it gets longer until you get to spring where it's equal night. Now it starts, it's gaining more heat than it's losing, so it's warming up. All right, so let's get this vocabulary here. We got the different stages, which is maximum tilt away and toward is solstice, and the maximum tilt, or when it's neither toward nor away, is called equinox. And so go ahead and equinox has equal night and day. That's, by the way, a Latin word. That's what it means. Nox means night. Solstice is the day of maximum tilt toward and away from the sun. Sol is a Latin name for sun. Okay, so solstice and equinox, write that down. Here's the vernal equinox, which is also what's called the spring equinox, summer solstice, autumnal equinox, and winter solstice, where winter is the maximum tilt away. But again, it's kind of interesting. The days are actually getting longer in the winter and getting shorter during the summer, but it's still gaining more heat than it's losing. Okay, now write this down. Here's where most of the writing happens, and there's one more big diagram we're going to do. Okay, the warm days of summer are caused by, and this is likely test question stuff like what's the point of this whole lesson? There it is. The warmer days of summer are caused by the longer days, because you get more hours of sunlight, but most important, the more direct angle of the sunlight, allowing more sunlight energy to be absorbed by the Earth's surface. Write that down. The more direct angle of the sunlight allows more sunlight energy to be absorbed by the Earth's surface. Okay, once you have that written down, now we have a diagram to write. Now this, again, having taught this, I already know, yeah, that's going to be a test question about what causes the warmer days of summer, I also am going to have you draw a diagram that I'm going to have you put it in your notes, and I'm going to put a similar diagram on the test, and you have to be able to identify the winter and summer solstice and the autumnal equinox and stuff. Okay, so get out your piece of paper again. What I draw, you have to draw as well. Okay?